object so indestructible, extreme and brutal that it could kill black holes. Gravestars. Cosmic soap bubbles filled with pure energy and with a shell made of the weirdest material that's possible in nature. What are they? What do they look like? And are they just a theoretical fever dream, or will they change our understanding of the universe forever? The birth of the most extreme objects in the universe. Very massive stars die in the most dramatic way possible, a supernova. We've explained this process in detail before, but in a nutshell, in less than a second, their cores collapse, crushed under their extreme gravity. The star's shell rushes in, bounces against the collapsing core, and explodes, shining brighter than whole galaxies. Depending on how massive the star was, there are two possible outcomes. Either the core compresses into a super-dense neutron star, or it kind of breaks reality and collapses into a singularity, an infinitely dense point with no size or dimensions at all. A place where the laws of the universe stop making sense and time and space are reversed. A black hole. Gravestars are a third, even expanding energy bubble. Like an ancient god hammering on its anvil, matter is trapped between an immovable object and an unstoppable force, forging a new kind of material that we've never seen before, but that we know is physically possible. And then it suddenly stops. A gravastar is born. What does it look like? Cosmic soap bubbles. Just like black holes, a gravastar can have any mass, but a typical one would be about the size of the London metropolitan area and as massive as 10 suns. The shell of the gravastar is utterly dark and the coldest thing in the universe, only a billionth of a degree above absolute zero. If we look at it in deep infrared, even the cosmic microwave background glows bright in comparison. How can anything made of matter be that cold? Don't all atoms jiggle back and forth? The thing is, the shell's not made out of atoms. It's made from an entirely new, unique and extreme matter that doesn't have a name yet, and that's at the very limit of what's physically possible in nature. Actually, the shell is so incredibly thin that atoms seem truly gigantic next to it. And yet, despite being ultra-thin, because it's been forged by two impossibly extreme forces, the shell is incredibly tight. So tight that if you wanted to stretch the whole shell by just 1 meter, you'd need the energy of an entire supernova. What about the inside? Well, it only gets weirder. The interior of a gravastar is perfectly simple, because it's sort of empty. The inside of a gravastar breaks our brains a bit because it's a sort of super condensed nothingness. What does this even mean? We'll have to simplify and use metaphors to make sense of what scientists measure and calculate. According to our current understanding of physics, particles like quarks, electrons, photons, and so on are not really solid objects, but sort of waves in an ocean. In our human world, you can't have waves without water, and in the smallest world, you also can't have particle waves without some kind of underlying, omnipresent cosmic fluid. This fluid is the vacuum, what we perceive as nothingness. It's the fundamental ocean at the bottom of reality. The waves of this vacuum ocean are the particles that make up you and everything else. But even when there are no waves or particles traveling through it, the fluid is still there, and like any fluid we know, it has inherent energy. Vacuum fluid is everywhere in the universe. The room you're in is 99.98% vacuum between the air particles bouncing around. Between the trillions of particles making up your cells, there's vacuum. But it's different inside a gravastar. When our star collapsed and condensed so violently, it was as if the universe took a cosmic pump and compressed as much vacuum fluid as physics allows, into a kind of super dense nothingness. As said before, even without any waves, the nothingness vacuum ocean of the universe has energy. But the superdense vacuum inside a gravastar has almost a billion, trillion times more energy per cubic centimeter than the vacuum outside the star. This is an unbelievable amount of energy and mass in a tiny space, just like, you may have guessed it, black holes. This intensely compressed vacuum ocean can't be compressed any further. It's at the absolute physical limit of anything that could be squeezed together without breaking physics, like black holes do. The ocean would love to stop being so tight. It wants to stretch out and flow back into the ocean that surrounds the star, but it's trapped in the safest prison possible. The shell, which itself is right at the edge of the physical limit of any material possible. An eternal stalemate. As you get closer, for details, we've made 1 or 2 videos on black holes before. If you fell into a gravastar, you'd be extremely dead before you even hit the surface, ripped apart and ground down by the gravitational forces. And once your scattered remains touch the shell, the atoms you were once made of would probably break down and dissolve completely, only to be converted into the vacuum energy of the interior, making the gravastar an infinitesimal bit bigger and an infinitesimal bit more massive. Okay.
Don't blame your brain lazy if you're struggling hard with procrastination, because it might be a result of childhood trauma.
Infinitesimal bit bigger and an infinitesimal bit more massive. Okay, this was fun and all, but what exactly is the point? Isn't this just another video of wild scientific speculation just for the sake of it?